Good. Just sharing the thing. Starting the class. I am super fine. Yeah, I'm fine. I'm all right. 110% all right. What happened? No, I don't know you. You have to say your name. You're one of my students. Then say your name. I'll come to know who are you. In absence of that, how I'm going to know that you're who are you? Oh, Vasant. Today holiday for you. You are not one of my student. You are my first student. Always special. You are my most talented student. Yes. Bless you with that. Okay, shall we start the class, please? Okay, fine. We are going to start the class, please. So last class we were understanding about Maharshi Kannad. Sir, what Maharshi Kannad told? Don't study. What Maharshi Kannad told? Hey, yesterday last class I taught you what Maharshi Kannad told is, ah, Maharshi Kannad, not voice Kannad. Maharshi Kannad talked about atoms. He said that atoms, he has given, proposed the word atom, and he is the one who has proposed the word anu. He told about anu and the subatomic particles as Parmanu. Understood. So Parmanu and Anu, he has exactly given the word. Got it. So after that we talked about chemical change, and after that we talked about nuclear change. So chemical change and nuclear change we have talked about. After that we came to know that there are two definite type of proportions we were talking about. In that first one, what we have talked about, that in a chemical reaction, law of conservation of mass is maintained. What is the meaning of law of conservation of masses? Atoms. Sir, what is the law of conservation of mass? Yes, but what is the meaning of that? Indestructibility means you cannot be able to destroy mass. Mass can neither be created nor be destroyed. So in a reactant to product phase means when a reaction is occurring, coming from reactant towards the product, actually what is happening is there may be loss, but the loss is exactly incurred. So definitely the most important thing here is in any type of reactions, whenever we are proceeding with the reactions, so total mass of the reactant will be equal to mass of the product plus mass of unreacted reactants. So those reactants which are exactly not going to react, that also will be present, and total mass will be there in the product side. So we have seen that one with calcium carbonate. Okay. So in calcium carbonate form, we have checked one thing, that is at the time when we were discussing about calcium carbonate, we came to know that when we are heating, so calcium carbonate will get heated and will get converted into calcium oxide and carbon dioxide. In the entire process, what is happening is this is 56 gram and this is 44 gram. So 56 plus 44 is equal to 100 grams. So 100 grams is coming, and 100 gram reactant side, 100 gram product side. So definitely mass is conserved. That's the important proof where we can say that mass is conserved. What we can say that mass is conserved. So now next part we are going to study today, we are going to talk about one reaction. Come on, check this one out. Note down this one. If 6.3 gram of sodium bicarbonate, Na2CO3, what is the chemical formula? Okay. Why? What happened? Is this not good? So if 6.3 gram of sodium bicarbonate is added to 15 gram of ethanoic acid, okay, for acetic acid, thank you. So if 63 gram of sodium bicarbonate are added to 15 gram of ethanoic acid, 15 gram of what acid? Ethanoic acid. So 15 gram of ethanoic acid and what you call sodium bicarbonate is there, Na2CO3. So we are going to solve this question. Let's check this one out. So 6.3 gram of sodium bicarbonate. So sodium bicarbonate is there, Na2CO3, and ethanoic acid is there, CH3COOH. Understood? So now it is exactly going to react together, and what? Okay. You can take our reference and you can study from that. Whatever is there, we are ready to do. We are ready to support everyone. It's not like that. So now look here. So sodium bicarbonate, Na2CO3 plus ethanoic acid, CH3COOH is there. Now what it is exactly going to give? Sodium ethanoate solution is there. That is the residue and carbon dioxide. So that is not the reaction. Here we are not standing to know the reaction. Here we are coming to know that what it is exactly going to, what is the weight and is it going to be conserved or not. Okay. So now let's see this one. Come fast, come fast, come fast. Now look here, mass of reactant. What is the mass of reactant here? Mass of reactant is given here is 6.3 plus 15. Now that is 21 gram, 21.3 gram. Mass of the product, that is the residue mass, first sodium ethanoate solution, they have given already. Check here, 6.3 gram of sodium bicarbonate. So sodium bicarbonate amount is given here is 6.3 gram. Sodium bicarbonate is exactly given as 6.3 grams. So here 6.3 gram is given. Next part is 15 gram of ethanoic acid. So this is 15 gram given. Okay. The residue left is founded to be weight of how much? 18 gram. What is the mass of this one? So carbon dioxide mass only we need to form. Carbon dioxide mass we need to find out. So first we will take the reactant. So reactant mass is 6.3 plus 1.5. So when we will be adding these 6.3 plus 1.5, 1.5 is there now? No, 15 is there. Yeah, 15, 6.3 is coming as how much? 21.3 gram. So check this one out. 21.3 gram is the reactant side, and we know that law of conservation of mass means how much is the mass of the reactant that will be equal to the mass of the product. Understood? So in this case, what we need to do, can we solve it? Sodium ethanoate and carbon dioxide. We are going to do this question. No problem, Anjali. So how much was there? First, what was there? Sodium bicarbonate was there. Sodium bicarbonate was there. What is the amount of sodium bicarbonate beta? 6.3 gram. And ethanoic acid was there. Note down, ethanoic acid was there. What is the amount of ethanoic acid beta? 15 gram. After that, sodium ethanoate was there, residue. Sodium ethanoate is there plus carbon dioxide was there. So sodium ethanoate plus carbon dioxide there. Can you tell me what is the amount of sodium ethanoate was there, beta? We need to find the amount of sodium ethanoate or carbon dioxide. We need to find the amount of carbon dioxide. But sodium ethanoate amount was how much? What was the amount? The amount of sodium with 18 grams. So 18 grams was given. So this is exactly coming as 18 grams. So definitely by law of conservation of mass of reactant is equal to mass of product. So 6.3 and 15 gram is there. So 6.3 plus 15 gram, that is the reactant amount. This is 18 gram plus X is there. Okay, because they wanted us to tell us, yes, that is 23.21 plus 3 gram. So here it is coming how much? 21.3 gram is equal to 18 grams plus X. Shift this one this side. So 21.3 minus 18 gram is equal to X is coming. Okay. So come on, tell how much is the quantity? Huh? So we are going to subtract it. Today brain is not working. So 3 is there, beta. 11 minus. So 3.3 grams. So X carbon dioxide residue is coming as 3.3 grams. So carbon dioxide gas amount is here. Here, what is the amount of carbon dioxide gas? 3.3 grams. That's it. Nothing extra you have to do. You do only one work. Arrange one chair for me. Just one chair, yeah, chair you give it. So it is exactly coming as, yeah, keep it there. Yeah, so 6.3, so it is coming as 3.3 grams. So 3.3 grams are coming. This is exactly the amount. So carbon dioxide amount coming here is 3.3 grams. Is it done? Where are the students? They are telling they are joining, and where are they? Is it done? No, that was easy, or this one easy? This one you understood now. So here reactant amount is always equal to product amount. So because reactant amount is equal to product amount, just make it equal and make it simple. Understood? Yes, thank you so much. Now we will be going with the next one. See, now we are going to talk about law of conservation, law of constant proportion. See, law of conservation of mass is a simple one. Everybody will be able to know about it. But what we are going to do is we are going to talk about law of constant proportion. What is the meaning of constant proportion? First, we need to understand the constant proportion. So, law of constant proportion is there. Just 1 minute now. Hello? Hello? Fine. So law of constant proportion is there. In that part, what we are going to study, So the law. हेलो दामू, मैं क्लास में हूँ, क्या हुआ बेटा? हाँ मैं, हाँ ठीक है, मैं देख रही हूँ। ठीक है, ठीक है, बाय। So now law of constant proportion. So what is the meaning of law of constant proportion? So you need to understand that law of constant proportion is also known as law of definite proportion. So if carbon dioxide is there means carbon dioxide, CO2 will be there means CO2 only. We cannot say carbon and oxygen is there means we can write it in any proportion. Okay. So carbon monoxide means CO only. Got it? So means one atom of carbon and one atom of oxygen, when they will be joining together, it is making carbon monoxide. So carbon dioxide means CO2. So the proportions are going to be fixed for a definite compound. Understood or not? So the proportion is not going to be changed. So when proportion they are telling it is fixed means we cannot change it. So most probably when we are talking about water molecule, it's not like na ki water molecule, when we are talking about the H2O is the water molecule, correct na? So H2O. So one day I will say H and O is more important in water molecule and I can write H2O2. No, H2O2 is hydrogen peroxide. What is that? Hydrogen peroxide. So hydrogen peroxide is different and H2O is different. Are you understanding that? So when we are talking about H2O, H2O is hydrogen. So that part is, ma'am, after this chapter, can you take a doubt class for science and maths? Yeah, I'm going to take that one. Don't worry about it. Smriti, hi. Understood, beta. So that is called as law of definite proportion. Now, Kanishk, understand one thing. A chemical compound always consists of same element combined together. Got it? So if somebody will talk about sodium chloride, so sodium chloride, whenever anybody is talking about, means it will always be made with sodium and chlorine, and the ratio is going to be fixed. The ratio is not going to change for anyone. Understood? Good evening, Anvi. So it is always going to be the same. That is sodium and chlorine. We can't change that. Come on. So when sodium chloride I'm going to talk about, so sodium chloride will be NaCl means NaCl. So it's not like today I'm writing NaCl, tomorrow I'm going to write something else for sodium chloride. No, the proportion and everything is going to be same. It is not going to change. Understood? So sodium chloride will be written like that. So now a chemical compound always consists of same element combined together in the same ratio, independent of method by which it is prepared. Understood? So we are not going to talk about how the reaction is proceeding, but we are only going to talk about what is the compound is, and the ratio of the element that is joining together in the compound remains the same. Like if I am going to talk about H2SO4, come on, check this one out. H2SO4. So if I'm going to talk about H2SO4, understood? Sulfuric acid. So if somebody will be talking to you about sulfuric acid, means that time you're not going to change, like now hydrogen is there, sulfur is there, and oxygen is there. So hydrogen, sulfur, oxygen is present there. So what is the atoms of hydrogen involved for sulfuric acid? 2. Sulfur involved for sulfuric acid is 1 and oxygen involved is 4. So that means it is going to be same every time. So no matter how many molecules of H2SO4 sulfuric acid we are going to take, the chemical composition remains the same. Understood? The mass that is involved in the reaction will also remains the same. So this is exactly H2SO4. I hope everybody might have understood this one. So this is called as definite proportion. Now we are going to check this one out. So now look here. So first example, water molecule is always found to contain how many hydrogen? Only hydrogen and oxygen. Only hydrogen and oxygen. So today I'm saying water molecule is containing hydrogen and oxygen. Tomorrow I will say water molecule is containing carbon and hydrogen. Is it possible? No. So water molecule is made with what? Water molecule is always made with hydrogen and oxygen. Understood? So carbon dioxide, if somebody will be asking you, so carbon dioxide will always be made with carbon and oxygen. We cannot change it. We cannot change it. That's the most important thing we must remember here. Okay. Now next one. And what is the ratio, beta? The ratio is 1 is to 8. What is the ratio? 1 is to 8. And the ratio remains the same. So what is the amount of hydrogen present there is 1, and carbon is oxygen is present there is 8. It is correct? No. It's wrong. Anyone who is present in the group can say it correctly. Actually, the correct thing present here is hydrogen atomic mass is 2. Oxygen atomic mass is how much? Come on, you can do it. Try at least one time. Come on and be. Anyone who is present there who can answer, because they got stuck. So I really want to ask from those people who are present in the group, they can answer this question. How ratio is coming 1 is to 8? How ratio is coming 1 is to 8? H2O? Atomic number. Yeah, atomic number is what? Oxygen atomic number is 8. Hydrogen atomic number is 1. How many hydrogen is present? How many oxygen is present? So, so is it atomic number or atomic mass? Let's check this one out. The ratio is coming as 1 is to 8. How the ratio is coming as 1 is to 8? First we need to check out. So that's very big confusion is there now. So let's clear out the confusion, please. Done? Let's check this one out. So H2O is there. What is the atomic mass of hydrogen? Atomic mass of hydrogen. So atomic mass of hydrogen is 1 U. We will write unified mass. Okay. AMU, atomic mass unit, or unified mass U can be we can put. Now how many hydrogen is there? 2 hydrogen is there. So 2 hydrogen having mass 2U. Oxygen, atomic mass of oxygen is, that's it, work over. Atomic mass of oxygen is 16U. Okay. Now check the ratio. And how many oxygen is there? Only one oxygen is there. So if only one oxygen is present, means the ratio is coming 2 is to 16. If you will cancel it, it is coming as 1 is to 8. So is it about atomic number or atomic mass? Mass. Did you rest? Did you understood it? Anvi, did you understood it? It's not about atomic number. It's about atomic mass. So only I asked you this much question, because once you will understand, you will never do mistake. So it's always about atomic mass. Come on, note down this one. Note down. Yes, Smriti. So this is about, it is about atomic mass only, and it is exactly coming as how much? It is coming as 1 is to 2 is to 16, that is 1 is to 8. And because of that only it is coming like that. I hope you might have understood. So 1 is to 8 is coming, ratio. Yeah. H2SO4. Yes, this is the law of constant proportion. Absolutely correct. That's exactly called as law of constant proportion, beta. Yes, it is called as law of constant proportion. Yes. Law of constant proportion. Law of constant proportion. This is exactly 16u. I hope everybody understood. Today, no student still now joined. They are thinking I'm going to start the session late. That's very nice. Now, burning carbon in oxygen. So, you need to understand one thing. When somebody will be asking you about burning carbon in oxygen, that's a type of oxidation reaction. What it is? Oxidation reaction. Burning of something is considered as what beta? Oxidation reaction. So in oxidation reaction part, how we are going to proceed? We are going to check carbon will burn in presence of oxygen, carbon dioxide gas will be. So by heating sodium, so everything when we will be talking about, so carbon dioxide always ratio will be 1 is to. Now let's see carbon ratio. Shall we check carbon ratio beta? Let's talk about carbon ratio. So when somebody will be asking you carbon dioxide, CO2, what is the atomic mass of carbon? 12. What is the atomic mass of oxygen? 16. But 16 into 2, how much it will come? 32. Understood. So 12 is to 32. What is the ratio coming here is 12 is to 32. So when you will be cancelling it, 4 threes are 12, 4 eights are 32. So ratio is coming as 3 is to 8. So we are not bothering how carbon dioxide is obtained. We are bothering what is the constant proportion. And here the constant proportion is always coming as 3 is to 8. The constant proportion is 3 is to 8. I hope you might have understood this one. So if somebody will give you for carbon monoxide, come on quickly do. What is the ratio beta? Come on, you can do it. Try. Carbon monoxide. 3 is to 4. Check. 12. And this one is coming as how much? 16. So 4 3s are 12, 4 4s are 16. So for carbon monoxide, the constant proportion is, carbon dioxide, the constant proportion is 3 is to 4. Today I am teaching very much important thing, beta, and you are absent. For you people only, I conducted the class today, and you are late. Now look here, beta. So this is exactly coming as CO is coming as carbon monoxide. The ratio is 3 is to 4. Here ratio is coming as 3 is to 8. So shall we go for the next one? Ready? Huh? So can you tell me this one? H2O2. Hydrogen peroxide. Hydrogen peroxide. What is that formula? Hydrogen atomic mass is 1. So 1 into 2. Done. Oxygen beta. How many hydrogen is there? 2 hydrogen is there. Okay. Hospital visit, no problem. Oxygen is 8 into 2, 16. Oh, sorry, 16 into 2, 32. 16 into 2 is coming as 32. So definitely how much is coming? 1 is to 16. So its fixed proportion is 1 is to 16, and it is not going to change. The fixed proportion is coming as 1 is to 16. It is not going to change. I hope everybody understood this one. Is it easy or tough? Ah, isn't it? So okay, we were talking about, see, if you can see 30 minutes of class already over. So with this, I'm going to explain better so that you can be able to understand. Actually, we were discussing about law of constant proportion. What is the meaning of law of constant proportion is, कि whenever you are writing a compound, the element proportion always remains same. It is not going to change. The element proportion always remains same. And we have given the example of water molecule, we have given the example of carbon dioxide, we have given the example of carbon monoxide. And one thing we have noticed there is it is not changing, it is not at all changing. Okay, fine. So it is not going to change. So now conclusion, what conclusion we have drawn here is carbon dioxide always contain the same proportion of carbon and oxygen. So no matter what is exactly the equation, the proportion is not at all changing. The proportion remains the same. Now we are going to talk about some exceptions also, okay? Because we are talking about constant proportion, so we need to understand about some of the exceptions also. So let's talk about the exception. The converse of this law that when same element combine in the same proportion, the same combine will be formed is not always true. That's the most important thing. See, you need to understand that when I am talking about calcium carbonate, listen carefully. So when I'm talking about calcium carbonate, at the time I'm talking about calcium carbonate, so we will be writing some proportion. Understood? But if I'm writing some proportion, that does not mean it is reflecting one only. Correct now? See, I'm just going to explain it in a simple way. Now understand this better. So if I'm talking about hydrogen, H2O, water molecule, H2O, so we know that 2 is to 16 is coming, it is coming as 1 is to 8. So that means hydrogen will always have this fixed proportion. Correct now? But this can be fixed proportion of any other element also now. Like it can be fixed proportion of NaCl also. 1 is to 8 is just a number. And it can be fixed proportion of any other compound. Correct now? It can be fixed proportion of any other compound. So we cannot say that this is always representing H2O. Are you understanding? Because this is just mere a ratio. So ratio cannot lead us to compound. Compound can lead us to ratio. Are you understanding? So if somebody will write like 1 is to 2, so 1 is to 2 can be the ratio of any other compound. 1 is to 2 can be ratio of any other compound. So if I am writing X2O and ratio is 2 is to 6. Understood? 2 is to 6. So that does not mean that 2 is to 6 is the ratio. This ratio is this. But this will lead you to this is not possible. No? Because that's 2 is to 6 is any number. 2 is to 6 is any number and reverse back going is exactly not possible there. Okay. So what we are doing here is we are actually going reverse means it is not possible. So only this is exception. This is exception or this is what you can say as limitations also. Exception, limitation, what is coming in your mind you can write about it. So that's the limitation part of it. I hope you might have understood this one. So now look here. So this, can you check this one out? CH4 and CD4. Check here. Ratio by mass 12 is to 4, 12 is to 8. So it is also not possible. See example, in this case of isotopes, the law of constant proportion is not followed. See another important point. When we are talking about the second exception you see very carefully. In case of isotopes, you know what is the meaning of isotopes? What is the meaning of isotopes? Say, what is the meaning of isotopes? I too don't know. See, the meaning of isotope is very simple. Atoms, same atomic number but different mass. Same atomic, write down. Write down. What is the meaning of isotopes? The meaning of isotopes are atoms having the same atomic number but different atomic mass. Mass is varying. So that's why they are called as isotopes. Same atomic number and different mass number is considered as isotopes. Chlorine is having 2 isotopes, oxygen is having isotope, and hydrogen is also having isotope. Hydrogen is having 3, deuterium, tritium is there, protium, I think 3 isotopes of hydrogen is there. So beta isotope means same atomic number but different mass number. Now look here, same atomic number but different mass, same atomic number like hydrogen mass is exactly, atomic number remains same, mass varies. So if it is exactly going to like this, so atomic number same, mass is exactly changing, then it is exactly called as isotopes. It is called as what? Isotopes. So chlorine is having 2 isotopes, Oxygen is also having isotopes. Iodine is having its isotope. The isotopes are exactly used in radiology. It can also be used for cancer recovery. Understood? They are used in chemotherapies. Okay. So many things are there. So isotopes, when we are talking about same atomic number and different mass, same element, same atomic number, but mass number is varying. So if mass number is varying means constant proportion cannot be attended. So its isotope will make different element. So like right now I'm just talking about CH4. Carbon isotope is present. So if carbon isotope will be present means it is the isotope of carbon, and this is exactly carbon itself, then definitely the mass variation will be there. Understood? The mass variation will be there. And if mass variation will be there means constant proportion won't be followed, because element wise both are carbon. Element wise both are element wise both are carbon. Element wise what they are? Element wise they both are carbon, and what is exactly changing here is mass. So mass wise they are exactly changing. Understood? So element wise both are carbon. Mass wise what is exactly happening is mass mass wise they are exactly varying. So we cannot be able to use constant proportion. Just 1 minute, beta. Video hang. Now is it breaking? It's okay now. Check one time. I don't think it is breaking now. Check. It's not breaking. Check. Okay na? It's okay now. I don't think so. It is breaking. It's not breaking. It's only breaking my head. Now look here. So here carbon two isotopes are there. What is the meaning of isotopes? The meaning of isotope is same atom, mass number different. That's the meaning of isotope. That's the meaning of isotope, and it's exactly not followed in case of non-stereometric compound like Fe3, 0.95, 0.98. It's exactly not going to be followed. Okay. So it is not following the case. Huh? So we can be talking about different isotopes. You can say that it's this law is also not non-stoichiometric compounds. That much is not needed here. You just remember these 2 points. Okay. Example: hydrogen and carbon. See, many elements are there. Their compounds are exactly considered as isotopes. So that's different. That's a different case. We can take care of that. Huh? Now look here. We are going to talk about 0.4 gram sample. I'm going to solve one question. Just check this one out. So 0.24 gram sample of compound of oxygen and boron was found on analysis to contain 0.96 gram of boron and this much of oxygen. So one sample is there, and in that sample, just listen very carefully what is exactly given there. Yes. So now listen here. What is exactly given there, beta? 0.24 gram sample of compound of oxygen and boron once found on analysis. So mass of compound is how much, beta? 0.24. Sample of compound of oxygen and boron. So oxygen and boron, they both combined, and how much it is exactly given? 0.24 gram was found on analysis to contain this much gram of boron. So specifically, how much is the gram of boron present? This much. And this much is the gram of oxygen present. Now they're telling calculate the percentage composition of the compound. Come on, first to write the question. Write the question I am going to solve. Why you are worried? Write the question I am only going to solve. Don't worry. Aru, patak. Why you are worried? I am there and I am standing here. I am going to solve. And the question is very easy actually. Hey, write the numbers. I'm going to solve. What is breaking here? Check one time. Now it is okay. Network issue might be there here. Yeah, I'm waiting only. Where I will go, I will stand here only. Are you finished? Written all the percentage now? Now look here. First understand, oxygen and boron, they both are combining to make a compound. So oxygen, boron, I, oxygen plus boron, they are making a compound. Okay. So what is the mass of compound? Can you tell me? What is the mass of compound? Say. What? You wrote the question, you say have to say me the mass of the compound. This is what you wrote now. 0.24. Yes. So mass of the compound is 0.24 gram. So what is the mass of boron? Mass of boron is 0.096 gram. Correct? What is the mass of oxygen? 0.144 gram. See, you need to understand that okay, when we are talking about the mass percentage, so mass percentage when we are discussing, you need to just realize only one thing there, that total amount of the compound is given as 0.24. Correct? Percentage means how much percentage I am present there. That is important. Correct now? So see, you people are present there means the total compound is made with me and you. Correct? So when total amount is made with me and you means we people are making one total compound. But what is my percentage there? So how to come to know? So mass percentage of boron. Mass percentage of boron means how much gram boron is present? And what is the total amount? Then this after two decimal cancel into 100 because percentage now. So into 100. So 3 3s are 9, 3 8s are 24. So here 20. So here how much is coming? 4 2s are 8. And here 4 2s are 8. Apro, how much percentage is coming? 20. 4 5s are 20. So it is coming in decimal. 3 5s are 15. 3 2s are 6 and 7 divided by 2. So 75, this much percentage is there. Let's check. How much is it? Oh, sorry. So only answer is not coming. 0. Composition is 0.096 by 0.24. So if this and this you are cancelling, then here 3 digit na, so one 0 will come. So it is coming as into 100. So it is coming as 9600 by 240. Cancel 320 1 2 3 8s are 24. So 8. So boron is present 40%. How much is the percentage of boron? 40%. And intelligent people will do only one work. If boron is present 40%, then oxygen will be present. That's it. Done. So boron is present 40% means oxygen will be present 60%. But we have to show that now. So mass percentage of oxygen. What is the amount of oxygen? 0.144 divided by 0.24 into 100. Cut 0 is coming. So 144 by 240 into 100 is coming. This cancel. 12 to the 12 times 6, 60%. So one is coming as 60% and one is coming as 40%. Done. So this is exactly coming as 60% and this is coming as 40%. I hope this question is easy for you to solve. So now we are going to go for the next one. Law of multiple proportion is not in your syllabus. Kill it, leave it. Reciprocal proportion is also not in your syllabus. Leave it, leave it. Dalton atomic theory. Yeah, we are going to absolutely correct. Okay. You solved, na, Arunisha? That's enough, Peter. Yeah, thank you. Now listen, Dalton atomic theory we are going to understand. I told you now, there were certain scientists in 1800 centuries, they were very much trying to know about atom. See, what exists, people want to know about it. Got it now? Means what you can see, you want to understand that it is existing. But what is not existing is what you cannot see, you believe that it is not existing. That's a very common belief, correct now? So but there are some people who wants to see beyond that part, who wants to see beyond that part. So definitely, what is the problem with it, yaar? I'm shifting this, it is going that side only. Fine. See, look at so Dalton atomic theory was based on many factors. So we need to understand. See, I told you, na, Maharshi Kannad talked about particles. He said that if I cannot break any atom, means if I cannot break something, that is the smallest part. Correct? Now, after that, we cannot break it. So one situation will come, but one particle will not be further broken. Got it? So they are considering it as the smallest one. They are considering it as the smallest one. But actually, what is there that based on that theories, assumption, what they have understood, John Dalton in 1808, he has proposed some of the theories. Okay, so this theory is very well known as Dalton atomic theory. What these theories are called as Dalton atomic theory. Now, one question we must ask from everyone: why this theory is so important? Because this theory is, some of the theories are exactly acceptable, some of the theories we cannot accept now because science has so much what you call now we are understanding the atoms and molecules in a very different way. Previously we tried to understand in a different way, now the understanding level is totally different. Then why we are knowing it in this phase like that? Got it now? This is the question everybody will ask, correct? So understand, this is exactly the first step towards understanding the atomic theory. So this theory will always be important because it has just put one stone after another stone, one stone after. So whatever discovery came, whatever we have discovered, whatever we have tried to learn, it was totally based on this one stone. Got it? So the theory is very important because till now the story is still important, and because of that only we are going to understand this part. Yeah, fine, I'm explaining that one, Anvi. So John Dalton proposed atomic theory of matter assuming atoms as ultimate indivisible particles. So when he was proposing this theory, he said that atom cannot be further broken down. His first concept was atom is the smallest particle. You are understanding? So that means the particle is exactly atom. It cannot be further broken down. That was the concept John Dalton was having. I hope you might have understood, Kanish, Sam. So means it is not going to be further broken down. If it is not going to be further broken down, means it is the smallest particle. Okay. So if I can't break a small sand particle, means it is the smallest particle. Understood? So that becomes the code. Close the gate. Close the gate. You heard that sound? Now look at. So now what are the postulates he has given? So he told that atoms are indivisible, means it cannot be further broken down. Okay. And the law of conservation of mass and law of definite proportion. So this is exactly he has proposed. So we are going to talk about this. The first is element consists of small indivisible particle called atoms. Atom take part in chemical reaction. This is the first part he told. Element consists of small indivisible particle. So element is made up of atoms. Till now we know this now. Element is made up of what, beta? Element is made up of particles. Element is made up of particles. Last time I am asking, say correctly. Element is made up of particles or element is made up of atoms? Atoms. Okay. So element is made up of atoms and atom cannot be further broken down. Atom cannot be further broken down. That was the concept. Element is made with atom and atom cannot be further broken down. Correct. So that is also correct. Till here it is okay. But atom cannot be further broken down. That part is wrong. Element is made with atom. That is correct. But atom cannot be further broken down is wrong. Atom cannot be further broken down is wrong. Because atom can be further broken down into subatomic particles. Subatomic particles like electron, proton and neutron. That is subatomic particles. Subatomic particles like electron, proton and neutron. Atoms of same element are alike in all respect. That is also true. Atoms of same element are same. So if I will take a bag of, yes, if I will take a bag of sodium, I will pick one sodium atom, another sodium atom. They both will be identical or different? Identical only. They both will be what? Identical. So that's what the element, the atoms of same element will always be identical. The atoms of same element will always be identical. Now atoms of different element are different. That's correct now. If I will take out sodium or if I will take out hydrogen, will they be same? No. They are called as atoms, but they are not called as atoms of what you call hydrogen atom is different, sodium atom is different, their structure is different, chemical property is different, physical property is different. Understood or not? So if I'm going to talk about carbon and if I'm going to talk about hydrogen, are they same atoms? No, they are elements, but they are different elements. So different element has different atomic structure. Same element is having same atomic structure. Same element is having same atomic structure. Different element is having different atomic structure. Now, atoms cannot be created or destroyed. That's the truth. Atom cannot be created or destroyed. Atom we cannot be able to create or destroy. And atom combined in food, small, fixed food. Atom combine in fixed small whole number ratio. Understood or not? So atom will be combining in fixed small number ratios, whole number ratios to form molecule. Whole number ratios to form molecules. So that's what now we know that the elements cannot be in a stable state. Some of the elements are not in the stable state and they need something to combine about. So some elements will be there which they will combine and they will make a compound or a molecule. Understood? So they will not be existing in free state, they will be existing in combined state. I hope you might have understood till here. What was the first, Sam? If your arrangement is done means, can you tell me what is the first postulate? Now say. Our Sam Maharaj is telling circle can be drawn anywhere. This is the first postulate. Every people is listening you. They'll make fun of you. You'll become super popular. All the students will talk you, take your name as circle only. No Sam, circle hereafter. What is the first postulate? Elements are made with elements. All the elements, always elements are made with atoms, and atoms are indivisible. So element is made with atom is correct. Atoms are indivisible. Is it true? No. Second postulate. Atoms cannot be replicated nor be destroyed. Come on, at least. Third one. Same element is having same type of atoms. Different elements. Next one is different elements are having different type of atoms. So 4 point we have discussed. The 4 point what we have discussed is there, but 5 points are there. So atoms combine in a fixed small number ratio. That's the fifth point. I hope you might have understood. So I'm going to keep it till here. Tomorrow I'm going to start with the same point.